Okay, this is section 2.2, and this section is entitled Subsets. To give you an idea of what subsets are, very simple concept. Subsets are just sets that you can make from stuff within a set. There can be many options for subsets. And so, to give you an example, thank you. To give you an example, I could say as a description, the set of students in this classroom who are on their way to a bachelor's degree. And that would be a set, that'd be all of you guys, right? Now, from within that set, I could say the subset of students who are on their way to a bachelor's degree who are women. And that would take a subset of you out of there. Does that make sense? As a picture, this might look like all of you on your way to a bachelor's degree. And this would be the men and the women. And then if we said the women who are on their way to a bachelor's degree, that might be all of these as a subset. Does that make sense? Okay? All right, so just a very basic introduction to subsets, okay? And so a quick note is that this notation that we're going to see for subsets, also known as your subset notation, is going to look like either this kind of like a C or a C with a line under it. This is the notation for subset. This is the notation for what's called a proper subset. Now, one way that students can think about this, or you guys can think about this, is that this C without a line under it is sort of like a less than sign. So, the subset or proper subset of women in this classroom is less than, right, the greater, right? There are less women than there are women and men combined. And you'll see that in a moment. This, the symbol for subset, is like, you can think of like a less than or equal to. It works for both. So we could say the women are a proper subset of the classroom. We can also even say the women are a subset of the classroom because this means less than or equal to. What's the key word? Or. Or means it could be both, right? But what if I said all of the students in this classroom? So if I just got rid of, I'm not paying attention to just the women now, all the students in the classroom, that, if I just label exactly that, the men and the women, that would not be a proper subset, would it? Because the men and the women equal everybody. Does that make sense? So proper subset is used when you're describing just everything besides the whole thing. Any combination of all of these besides the entire one, that's exactly it. Subset can be used for both all the little combinations and the actual set itself. All right? Okay? So if you don't totally understand that yet, it's okay. We're going to get plenty of practice with it. All right? So let's take a look at this problem. Select subset or not a subset. Now, they haven't even talked about proper subsets yet, but I just wanted to introduce that concept because we're going to get there. So, select subset or not a subset. Remember that this means that it can be less than or equal to the one on the right. And you always read it left to right. So let's take a look. This set consists of 4, 1, and 8. This set consists of the natural numbers 1 through 11, right? Is this a subset of that one? Yes. It is. Absolutely it is a subset. Why? Because we can find all the elements of this set in that set. just as a quick question, is this a proper subset? Yeah, it is, because it's less than that one, right? It's less than. So you could say that too. Regardless, don't stress it if you don't understand proper subset just yet. We'll get there. All right, next. Okay, taking a look at this one. -10, 0, and 10. The set that contains these three elements. How about, is that a subset or not a subset of the one on the right? It's not a subset. It's not a subset because this would have to have a 0 in it. Does that make sense, guys? It would have to have a 0. Okay? You always read left to right. Let's take a look at the next one. Select subset or not a subset for the blank. The set consisting of the elements Thursday and Monday. To the right, that set. Subset or not a subset? Not a subset. Why? You got to be able to find everything here over there to be able to call subset. If you're, like, let's say this was just Thursday, right? Would it be a subset? Yes. If this had Monday in it, would it be a subset? Yes. Does that make sense? So those are two ways that you can look at it. Okay? So the answer to this one is that it's not a subset. All right, next. Take a look at this one. Subset or not a subset?
Subset.
It is a subset because it follows the what little extra criteria? It's the equal part, right? In this case, this is a perfect example of a subset that happens to be the set itself, because order doesn't matter on the terms. Now, quick question, let's see if we can come back to this. Is this a proper subset of the one on the right? No. This set on the left, because you always read left to right, the set on the left is not a proper subset, because why? It's not less than it, is it? It's the same one. So, subset contains all the ones that are less than it, all the different combinations of the smaller sets that you can make, and the one that's exactly the set itself. It can be both, either one. You can use this for any of those. Proper subset contains or has all the options for all of your smaller ones, okay? But not the equal to. Hopefully you're getting a little bit more confident with that, but we'll get better. Okay, how about this one? Subset or not a subset? It is not. And here's the thing. They have to be identical. It has nothing to do with transposing, reciprocal, anything like that. If there's a 12 over 15 here, there better be a 12 over 15 there. If there's a 2 over 11 here, there better be a 2 over 11 there. It has nothing to do with transposing, reciprocals, anything like that. In this case, this is not a subset. Okay? All right, let's take a look at this one. Tricky question. Subset or not a subset? Okay, I hear not a subset. Anybody think it's a subset? Okay, how about I help you with this? Empty set, can we write it as this? Yes, right? Now, before there was A, B, C, and D in this set over here, what was there? It was empty, right? In other words, before I have a basket that has nothing in it. I have a basket with nothing in it. And then I have another basket over here with nothing in it. Are they the same at this point? So, this basket with nothing, this one. This basket with nothing, that other one. Now I put A, B, C, D in there. Is this a subset of that? It is, because at one point, emptiness was part of that. So another way to think about it is, this one was empty. This is the empty. This set is empty. A, B, C, and D. Does that make sense, guys? And so is empty in there? It is. Empty is in there. So therefore, this is a subset. Just want to verify, just in case you're following along in your homework or you're on paper or on your computer, it is. Does that make sense, guys? Okay, so when you see problem number 6, if you're working alongside me, you know. All right, let's take a look at this. All right, so now for the first time, we see determine whether we're going to use subset notation, proper subset notation, both, or neither. Let's understand this. This can be tricky, but we're going to do a good job here. Let's take a look. So we have all of these choices. If it doesn't end up here, we'll choose none of the above, all right? So first question for you, the set consisting of 3, 8, and 11. Is that can we find that in here?
Yes.
Yes, right? So could we use proper subset notation for that? Yes, absolutely. Everybody agree? This works, doesn't it? Because this set, everything here can be found in here, and it's less than that, right? Okay? Could we use the subset notation?
Yes.
Yes, why? Because what key little word?
It's less.
Or. Because this works for both the less than or equal to case. This one is just the less than, right? Just the less, that's okay. So that's just the less than. So this is one extra set, right? This is all of your sets that you can see here, plus the one that's equal to it, right? So we could use this one. So therefore, what do we conclude? It's both. Does that make sense, guys? We can use both. All right? And so if you're following along, you want to check it, there it is, both. Okay? Next, let's take a look at this one. And if it's none, then we'll come down and select that. All right, so 0, the set consisting of 0, 2, 4, 6, and 8. Remember, always read left to right. We're comparing left to the right. And that one, does the order matter?
No.
It does not matter. So now let's go and answer it. Can we use the proper subset notation? No, because this set is equal to. This is not an option because it's not a less than case. It's your one that's equal to that. So therefore, you can only use the less than or equal to option. Does that make sense, guys? Okay. Very, very tricky. Sometimes can trip you up, but more and more practice. That's why I started introducing it early. So by the time we got here, it was no big deal. Okay. All right. Let's move on to this next one. All right, so before we can even do anything, what we have to do is figure out what that set on the left is describing, right? So let's take a look here. What I'm going to do is just set up some braces, and let's go figure out what's going on. Our set has to have what in it? What do these have to be? Natural numbers. And what else do they have to be? Between
greater than 3 and less
greater
than
than 3 and less than 5, which leaves you only with what? 4. Okay, so our set on the left consists of 4. What is this one? An empty set. Okay, now a moment ago, I said that the empty could be a part of something. But can a set that has something be a subset of a set that doesn't have anything? No, it cannot. So pay close attention to that. Now, if I reversed it, would that work? It would. But 4, the set consisting of 4, is not a proper subset. You have to see at least a 4 here, right? It's not a subset because you'd have to have, again, at least a 4 here. So therefore, if it's neither of these, it can't be both. What do we choose? None. Does that make sense, guys? All right, any questions about that at all? Okay, let's keep rolling. Okay, is that 0 over there the empty set?
No.
No. It's just a 0. As a reminder, these are notations for empty set. Empty set, or you can even have both. These all mean the same thing. But just a 0 is just a 0. Does that make sense, guys? All right, so with that said, let's take a look at this problem. And this is a very, very important thing here, so pay close attention. Last section, we had that element symbol, right? And last section, you recall that we had something like 0 might be an element of the set 1, 2, 3, and 0. And on your previous night's homework, you were given a problem like that, and they'd say, determine whether that's true or false, right? And what's the answer, of course?
True.
It's true, right? True. Is it still going? I sure hope so.
Yeah.
Oh, thank goodness. All right, thank you. So 0 is an element of that. You would have said in your previous night's homework that that is true, right? Everybody agree? Okay. Now, we have a problem that looks very similar to this, except we have subset notation. Now, based on the work that we've done before, would you say that this is true? Yes, you would say it's true because you would say 0 is a subset of that, right? Because it's less than that, right? You can find 0 over here. But this question is actually false on a technicality. The technicality is that when you're dealing with subsets, in order to even speak the language, it has to have braces around it. Okay, one more time. Probably a couple more times, actually. So, when you're in this section, if they asked you a subset question, the item on the left better have braces on it to even get started. If the item on the left has no braces around it, you can't even get off the ground. It's immediately false. Does that make sense? And let me give you another item here. So we know that if we're talking subset notation, that would be true. Everybody agree? That's true. Let me give you 2 examples of false. All right? Let me give you 2 falses. This is a big false. Why do you think that's a false? Because it has braces. When you're speaking element language, the one on the left has no braces. Okay? When you're speaking subset language, if you have if your item on the left does not have braces, it is false. Does that make sense? So you have to pay super close attention to the language you're speaking. Okay? So if you see an element symbol, this guy's got to have, or the guys, whatever, have to have no braces to get off the ground, to even start talking, to even start thinking about whether it's true or false. Over here, if you're talking subset notation in language, the element or set on the left or items on the left better have braces around them to start talking. Does that make sense? If either of those aren't happening like you see in these examples, you can immediately jump to the conclusion that it's false. Does that make sense? And we're going to have some more practice. But this requires a little explanation. Otherwise, you'll get them wrong every time. All right, so there you go. Let's take a look at this. So we now know from that long explanation that the answer to this is immediately false. Now, if I put braces around it, it would be true, because we can find 0 over there. All right, so this is indeed false, as you can see. Let's move on to the next problem. Now, can we start talking?
Yes.
We can, can't we? We can start considering if this is true or not, because this has braces, subset notation.
It's true.
It is true, right, everybody?
Yeah.
They're saying, is the set consisting of 1 a subset of the set consisting of 1, 4, 3, 2? Notice the language. Set, subset, set. All talking in terms of sets. This would be saying, is the element 0 a subset of this set? See why the language is wrong? Coming over here, is the set consisting of 0 an element of this set? Notice the language is wrong. Okay? So super, super important that you guys understand that, or you might get several problems incorrect. So this, of course, is true. Let's go on. I won't, select. It's fine. Now, this could be a trick question. What is your initial reaction to this?
Well, it's an empty set.
It's an empty, what was the key word? Set. Even though this doesn't have braces around it initially, and you want to say it's immediately false, what did we say this is? This is the same thing as that, meaning that, could we not also replace it with that? Are we talking the same languages? Yes, we are. Set, set, set. All the same language. Just because this doesn't have braces around it, it's the one thing that is interchangeable. Does that make sense? That's why it's a trick question. So, the empty set, is the empty set a subset of this? We talked about our baskets.
Yes.
Yes, it is. So this is true. All right. Super, super important. Good job. Nicely done. All right, here we go. Let's see if you get this. Take a moment to look at it.
It's true.
Perfect. We got a split room.
Double brackets?
Think about it.
Maybe.
Think about it. In this case, are the braces used to denote a set? The first round of braces. Are these right here meant to be set braces? It would seem so, except on the other side, we have this, and then you have elements that are surrounded by braces. Now, what if I said this? Would that be true? So the braces in this problem around the 6 and around the 13 individually, are those just decorations pretty much? They are. They're just decorative. They're not meant to be functioning braces. Because what's going on here is this is the actual element itself, just like a smiley face is an element. What if I did this? Smiley face with braces around it, that's the element. Would this still be true?
Yes.
Yes. If I did a little hat, would that still be true?
What is
Yes.
the purpose of doing that, though, adding the context?
Because it's just to confuse you. So see if you really understand it. Now, let me ask you a follow-up question. What if I did a double round here? Now it would be false. Does that make sense, guys?
Why?
Because the first round is just decorative, but the moment I do another round of it, I'm now saying this is a set consisting of that element. Does that make sense? Okay, so this problem is true. It is
So
true.
what if there was no brackets on the 6 and the 13? Would that be considered false?
Correct. So for example, if there was nothing here, then you would be speaking set notation in element notation. Does that make sense? So, see that? This set of braces is grouping that. This set of braces is... Alright, question number 14. Let's determine whether the given statement is true or false. Subset, or the set consisting of 5, 10, is not a subset of the set consisting of 10, 5. That's not true. This is a subset of that. They're claiming that it is not a subset, so therefore this question is false. In fact, they're equal. Okay? Next question. List the subsets of the given set, B, K, and Y. Well, very easy to do something like this. So what you're going to try to be doing is list every option. First option is always going to be your empty set. Then the next options will be your individual elements. Notice everything I'm listing here can be a subset of this larger set, or our starting set. Then we list our next ones, BK. What else? BY. Anything else there? And KY. And then finally, we have to take into account the set itself. So those are all the possible ways that we can create subsets from this given set. And so if you take a look at your options, the one that works is D. Empty set B, K, Y, BK, BY, KY, BKY. Okay? All right. Now, for this next one, they want you to first calculate the number of subsets, then calculate the number of proper subsets. Check the video. This is actually very easy. You don't need to go and list every single thing like we did in our previous problem and then count it up. So for example, this one, the number of subsets is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 subsets. But we don't have to go and go empty set, 18, 0, 13, 17, 18 and 0, blah, 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 blah. You don't have to do that. There's an easy formula to get that. To calculate the number of subsets that you can make from that, you simply take the number 2 and raise it to n, the number of elements in your set. So, taking a look at this, the number of subsets is the number 2 raised to the power of how many elements are in your set. If there were 3, it'd be 3. If there were 10, it'd be 10. But in this case, it's 4. Okay? And 2 to the 4th is 16. So there are 16 possible subsets that we can create from this set. From a set of 4 elements. This one, there are 8 possible subsets, and you can check it. This is what? 2 to the 3rd power. Because there's 1, 2, 3 elements. What's 2 to the 3rd? 8. Sure enough, there are 8 subsets that we can create. Now, proper subsets, as we discussed, is always everything that you can find in subsets minus 1. Because you don't get the set itself. So it's super easy. Once you've figured out the number of subsets, simply take away 1. There are 15 proper subsets. And there it is. 15. Done. Next. So taking a look at this next one. Go figure that one out. There are how many elements in here? You don't have to go and list it out to go figure out how many subsets you can create. There are 1, 2, 3, 4, 5 elements. So we would take the number 2, that's just part of the formula, to the power of 5. That means that we can create 32 possible subsets from these 5 elements. And of course, the number of proper subsets is super easy, just 1 less than your subsets. Okay? So on this next one, the only reason why this one's a little more tricky is because you actually have to go and create your set yourself. So this set is going to be the natural numbers between 8 and 14, which would be 9, 10, 11, 12, and 13, right? 9, 10, 11, 12, 13. And now you can use your formula, 2 to the 1, 2, 3, 4, 5th power for your subsets, and then minus 1. I'm not going to do that. All right, last 2 problems. Let's take a look at this. And so, I'm going to erase this right here so we can read it a little easier. even if you can't see the chart here, it's not really relevant to this problem. What's relevant is you can see that they're claiming R is a subset or a proper subset of T. So we need to go over here and look at the key. The key to this chart says R is the set of tattooed Republicans. T is the set of tattooed Americans. So therefore, what their claim is that the set of tattooed Republicans is a subset of all tattooed Americans. And that would be true, because if you looked at all the Americans, you could find also all the Republicans within that. So this is true. This statement is true. Let's move on to the last question of the day. And again, you don't really need to know what's going on with all these numbers. You just need to know what each of these letters represent. So the statement here is that if a person is a Republican, R, so if a person is a part or an element of the Republicans, so if the person, in other words, is a Republican, then that same person must be a pierce. This is a piercing, people with piercings. So if the person is a pierced Republican or is a Republican with piercings, or a piercing, then that same person is or must be a pierced Republican woman, which is completely not true. It should be the other way around. And let's take a look at our options. So it's not true. Let's look at this. The best option is what? B. If a person is a pierced Republican woman or a Republican woman with a piercing, then that person must be a Republican with a piercing, and that's it. Okay? And that will do it. That last one is for you to do.